The Starship program has now completed 10 flights, marking a journey filled with both impressive achievements and notable setbacks. SpaceX's teams have weathered explosions and technical failures, but have also celebrated remarkable successes such as flawless re-entries, the catching of boosters, and even the groundbreaking reuse of a booster. As the program reaches this milestone of 10 flights, it stands poised on the brink of a new era, one defined by advanced vehicle designs and the potential routine reuse of ships as early as 2026. Flight 1. Just getting off the ground. SpaceX began Starship flight testing in April 2023 with its inaugural mission, Flight 1. This first flight featured the pairing of Ship 24 and Booster 7, both debuting the powerful Raptor 2 engines and having undergone the most comprehensive testing regimen in Starship history. They completed no less than 15 cryogenic tests to validate tank integrity at cold temperatures, 19 spin primes to activate turbopumps, 10 static fires to check engine ignition on the pad, a wet dress rehearsal simulating a countdown, and even experienced a launch attempt that was aborted, all these before launch day. Despite this exhaustive preparation, the mission did not go as planned, but the goal was simple: clear the launch pad safely. From liftoff on April 20, 2023, Booster 7 lost 3 engines almost immediately, eventually shutting down more engines during ascent. Coupled with a fire erupting in the engine bay, these issues led the stack to disintegrate at around 40 kilometers altitude. That engine bay fire burned through critical electrical lines, causing loss of booster control. Adding to the drama, the Flight Termination System (FTS), designed to safely destroy the vehicle, was insufficiently powerful to obliterate both stages, only puncturing tank walls. Launch conditions also revealed a glaring pad issue. The water deluge system intended to protect the concrete pad hadn't been installed yet. SpaceX took a calculated risk by flying Flight 1 without this system, relying on the concrete's durable Fondag foundation to survive a single launch. Unfortunately, the exhaust blasted through, forming a crater beneath the pad and creating a spectacular plume of dust, reminiscent of a volcanic eruption. In response, SpaceX strengthened Pad A's foundation, added a protective water deluge plate to absorb sound and shield the pad, and introduced a hot staging system atop the booster to improve stage separation. To combat the destructive engine bay fires, a large fire suppression system was installed, featuring 2 stainless steel tanks mounted under lateral structures near the booster's quick disconnect. These tanks release CO2 to smother fires before they can damage critical engine control wiring. Furthermore, the FTS was doubled in explosive charge to ensure future flights could be terminated decisively if necessary. Flights 2 to 4, learning and improving. Lessons from Flight 1 informed the next test flights involving Ship 25 and Booster 9. Thanks to abundant data collected previously, these vehicles entered flight testing with fewer preliminary tests. Launching November 18, 2023, Flight 2 displayed all 33 engines firing perfectly during ascent, revealing a mesmerizing mega-diamond effect, where supersonic engine exhaust creates a unique aerodynamic signature resembling an aerospike. Hot staging worked flawlessly on the first attempt, and Ship 25 ascended towards space. Unfortunately, Booster 9 was lost during the boost-back burn phase due to ice forming inside the tanks, which clogged engine pump inlets, a recurrent problem caused by how SpaceX uses autogenous pressurization gases tapped from the Raptors. Near the flight's end, a fire in the aft section doomed the vehicle just before second stage engine cutoff, SECO. Investigation revealed the fire resulted from dumping excess liquid oxygen, LOX, through aft skirt valves during flight. Thus, ice filters were added to the LOX turbopump inlets to prevent debris ingress, and the oxygen dump was rescheduled post-SECO to minimize fire risk. Nonetheless, aft fires would plague future tests as well. Flight 3. Launched March 14, 2024. Advanced booster performance with Booster 10, clearing the boost back burn and reaching landing burn initiation. However, it was lost shortly thereafter, possibly again due to ice blocking LOX turbopump inlets. Ship 28 reached SECO, but suffered attitude control loss after roll control thrusters became clogged, leading to an uncontrolled re-entry. For subsequent flights, enhancements included further ice protection on boosters and added redundancy for the ship's roll control thrusters to mitigate the loss of attitude control. Flight 4 on June 6, 2024, marked a significant step forward. Booster 11 executed its entire mission profile and achieved a gentle splashdown in the ocean. Ship 29 performed a complete ascent burn, coasted in space, and executed a fully controlled re-entry. The heat shield showed signs of burn-through and nearly lost a forward flap, but provided uninterrupted live video of re-entry. A first for Starship and a remarkable achievement. Flights 5 to 6. The catch and rapid reuse ambition. With Booster 11's successful splashdown, SpaceX aimed even higher, planning to catch the booster on the launch tower rather than have it land in the ocean. To prepare, they strengthened the launch pad significantly. New bumpers were added to the landing rails, gusset plates installed to reinforce tower structures, and other upgrades deployed. Flight 5, launched October 13, 2024, featured Ship 30, equipped with an improved heat shield. Besides the tile-based system used previously, this version added an ablative layer beneath the thermal tiles to better tolerate the intense heat of re-entry. The hybrid heat shield consists of attachment pins securing insulating felt, a mesh to hold the felt, and the tile surface, all now supplemented with ablative material to enhance durability. In a historic moment, Booster 12 completed a flawless mission and was successfully caught by the tower, a feat rare in aerospace history and a tremendous demonstration of SpaceX's vertical integration. Meanwhile, Ship 30 executed a perfect re-entry and splashed down exactly on target in the Indian Ocean. Although some burn-through occurred, the ablative layer functioned as intended, marking the pinnacle of Starship's early successes. Remarkably, SpaceX has yet to replicate this mission's exact success since. Flight 6 followed swiftly, lifting off November 19, 2024, only 37 days after Flight 5. Demonstrating the fastest launchpad turnaround yet. This was the final flight of the Block 1 Starship iteration before transitioning to the upgraded Block 2. Booster 13 performed a clean ascent, but could not be caught due to a tower issue, so it ended with a splashdown. Ship 31 met all its mission goals and floated safely in the ocean, despite only having ablative protection on critical heat shield sections. Conducting this flight in daylight rather than dawn allowed clear visual analysis of thermal shield performance post-re-entry. Flights 7 through 9. Block 2's rocky begin, Block 2 Starships.